Hello, my dear children. Welcome to the mathematics class. Today we are going to discuss integrals. We are going to discuss integrals. In this chapter, we are going to discuss the concepts of exercise 7.6. The concepts of exercise 7.6. In the previous exercise, we have learnt how to integrate a rational function by partial fractions method. I hope you have learnt well. I hope you understood well. Isn't it or not, my dear children? Right. Now come to this exercise 7.6 concepts. Are you ready to listen the class, my dear children? Right. This is another method. This is another method of integration, that is integration by parts. This method is called integration by parts. As you know, the product rule in the differentiation d by dx of uv, here also there is a product rule. If u and v are two functions in x, then integral uv dx, u means here first function in x and v means another second function in x, then the integral of these two functions is equal to u means here first function, u into integral v dx minus integral of du by dx into integral v dx whole dx. You have to remember this formula, my dear children, for integrating integrating by parts. Okay, my dear children, integral uv dx is equal to u integral v dx minus integral of du by dx integral v dx whole dx. This formula can be written in the form of sentence like this, that is, the integral of the product of two functions is equal to first function, this is first function, into integral of the second function, this is integral of the second function, minus integral of differentiation of the first function, this is differentiation, this part denotes differentiation of the first function into integral of the second function. Understood this point, my dear children? Now we integrate a function by parts method, integration by parts method. Now you have to remember this point also. Note, in the product of the two functions, in this product there are two functions are there. Not more than two functions will be given. Okay, my children. The most cases, at most three functions, not more than three functions in our course of study. Okay, my children. If one of the two functions is not directly integrable, example log x, we don't know integral log x formula, sin inverse x, integral sin inverse x formula we don't know, integral cos inverse x, do you know integral cos inverse x formula, my children? Integral tan inverse x formula we don't know. So for all these functions etc, for all these functions we don't know integral. In this case we take it as a first function. In all these cases we take it as a first function and the remaining function is taken as the second function. In the product of these two functions, if sin inverse x, cos inverse x, tan inverse x or log x, like this, if any function is there which is not integrable directly, that function is taken as the first function. Remember this point, my children, in this method of integration by parts. Okay, my children, the second function is a remaining function. Remaining function is taken as the second function. If there is no other function, then unity, that is 1, is taken as the second function. Sometimes they will ask you integral log x dx, integral log x dx. In this case we don't know what is the second function. We have to take it 1, means log x into 1. First function is taken as log x and second function is taken as 1. Then we find integral log x by using integration by parts method. Okay, my children, remember this formula. Okay, my children, memorize this sentence. Okay, my dear children, understood? Right. Come to the important point, second point, note 2. Note 2. We can also choose the first function as the function which comes first in the word isolate. This word is very important for integration by parts, my dear children. Please remember this word isolate, where I stands for the inverse trigonometric functions. Example, sine inverse x, cos inverse x, tan inverse x, etc. Okay, my children? Right. Next letter L. L stands for logarithmic functions. Okay, my children, is it clear? Next, third letter is A. A stands for the algebraic functions. Algebraic functions means x square, 2x, like this. Okay, my children, understood this point. Next, fourth letter is T. T stands for the trigonometric functions. Means sin x, cos x, tan x, etc. Okay, my children, understood? Right. Next, last letter E. Fifth letter is E. E stands for the exponential function. Example, a power x, e power x, etc. Okay, my children? Right. By using this second point, this is very important point for integration by parts. Okay, my children? Right. When the two functions are arranged in this order, in the product of the two functions, we should arrange the two functions in this order only. Here five letters are there. In this order we have to arrange the two functions, then it is easy to find integration of that function. Okay, my dear children, then we can easily apply integration by parts method. Okay, my dear children, remember this point. Right. Here you have to learn one more integral formula. Integral e power x into f of x plus f dash of x dx is equal to e power x into f of x plus c. It means integral outside e power x will be there. In the brackets, one function will be given plus its derivative. One function and plus its derivative will be given in this square brackets. Then the integral of this function is equal to e power x. We write e power x as it is. Then e power f of x. Okay, my dear children. Remember this formula also. Okay, my dear children. We use this formula also in this exercise. Okay, my dear children. Right. The concepts of the exercise 7.6 were completed. Okay, my dear children, please learn the concepts of exercise 7.6, my dear children. Right. Now come to the questions, problems in the exercise 7.6, page number 327 in the textbook. Okay, my dear children. Right. Come to the question number 1. First question in this exercise. Integrate x sine x. We have to find the integral of x sine x. Okay, my dear children, understood this question? Right. Now come to the solution part. Let us assume that capital letter I is equal to integral x into sin x dx. As we followed for the previous questions, here also first step is we are assuming that given function is capital letter I. Okay, my children, understood this first step. So here we are using integration by parts. So when you are using the integration by parts, first of all you have to identify in this product of two functions which type of functions these are. Here first function, what is the first function? X. It is an algebraic function. Here first function, this x is a algebraic function. What is the second function? Trigonometric function. First function is algebraic function and second function is trigonometric function. In this word, see that two letters in the same order or not? A, T, in the same order. Isn't it or not, my children? So we can directly apply integration by parts method here. So, okay, my dear children. Sometimes they will give like this in the reverse order, integral like this. find or integrate sin x into x. In this way, in this order, they will give the function, the product of these two functions. In such case, you have to rearrange these two functions. You have to rearrange these two functions because this is a trigonometric function, this is a algebraic function. So we have to rearrange in this order only. Okay, my children, understood this point? Is it clear this point, my children? Right. Now, this is the first function and this is the second function. These two functions are arranged in the same as in this word. Okay, my children, algebraic function, after that trigonometric function. Now, in your mind, consider this a first function and this is a second function. So, what is the formula? First function into integral of second function minus integral of, you have to learn that sentence, my children. You have to memorize that sentence. In first function, integral of second function minus integral of d by dx of first function. What is the first function here? X. D by dx of first function integral second function whole dx. Okay, my children, understood this point? Okay, my children, right. So, by using the integration by parts method, we wrote this sentence. We wrote this step. Understood this step, my children? I repeat this step, my children. This is the first function. This is the second function. We arranged. Already they are in the same order. So, no need to worry here. Directly we can apply integration by parts method. So first function here, first function is x into integral of second function. What is the second function? Sin x. So integral sin x dx minus integral of d by dx of first function. What is the first function? X into integral of second function, integral sin x dx whole dx. Okay, my children, understood this step? Right. Now we find out the values of the terms. X into, what is the integral sin x dx? Minus cos x. Okay, my children, integral sin x dx value is minus cos x minus integral of, what is the value of d by dx of x? 1 into integral sin x dx value minus cos x whole dx. Understood this step, my children? Because integral sin x dx is equal to minus cos x and d by dx of x is equal to 1. By using these two formulae, integration formula and differentiation formula, we used these two formulas and we wrote this step. Understood this step, my children? Right. Now, what do you get here? First term, x into minus cos x. X minus x cos x. Okay, my children, understood this first step? Right. Here, integral, here minus is there. Integral 1 into minus cos x. What will you get? Minus cos x. Already minus is there. So, minus of minus, what will you get? Plus integral cos x dx. Understood this? Integral cos x dx, my children. Here in this brackets, we get 1 into minus cos x means minus cos x. Integral minus cos x dx. So already minus is there, we can write it outside. So minus of minus plus integral cos x dx. Okay, my children, understood this step? Right. Is equal to minus x cos x plus integral cos x dx. What is the integral cos x dx formula? Sin x. So integration part is over. So finally we write constant of integration because integral cos x dx is equal to sin x. So this is the integral of x sin x dx minus x cos x plus sin x plus c. Okay, my children. If you find derivative, if we find the derivative of this function, finally you get x sin x. In the reverse order, if you find the derivative of this function, finally you get x sin x. Okay, my children, understood? Right. Come to the next question, question number 2. Integrate x sine 3x. Understood this question, my children? We have to find integral of x sine 3x dx. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral x into sine 3x dx. Okay, my children, understood this step? Right. Here we have to find integral of product of these two functions. Means we have to apply integration by parts method. So first of all, we have to identify which type of functions these are. Here first function is x and second function is 3x. So it is an algebraic function x. Here sin 3x is a trigonometric function. So here see algebraic function, trigonometric function. AT in the same order. The functions are in the same order, which is convenient to integrate easily. Okay, my children. Right. So no need to rearrange these functions. Directly we can apply integration by parts method. Okay, my children. So in your mind, you have to assume that this is the first function, this is the second function. So that is equal to first function into integral of second function minus, you have to memorize that sentence, my children. Integral of d by dx of first function, that means d by dx of x, into integral of second function whole dx. Okay, my children, by applying the integration by parts method, we get this sentence, we get this step. Okay, my children, understood this step? We assumed here this is the first function, this is the second function. So according to that sentence, first function into integral of second function minus integral of d by dx of first function into integral of second function. Okay, my children, we substituted these two functions in that sentence. Okay, my children, understood this step? Right. Is equal to, that is equal to x into, it is in the form of integral sine of ax plus b. It is a linear function in x, linear expression in x. So it is in the form of sine of ax plus b. What is the formula? Integral sine of ax plus b minus cos of ax plus b by a. I will write that formula also, my children. Okay, minus cos of ax plus b by a minus integral d by dx of x. What will you get? 1. We get the same answer here also. Minus cos 3x by 3 whole dx, because integral sine of ax plus b dx is equal to minus cos of ax plus b whole divided by a. Okay, my children, by using this integral formula, and d by dx of x is equal to 1. Differentiation formula also used, and d by dx of x is equal to 1. In this step, we used this integration formula and this differentiation formula. Okay, my children, for this one we used this formula, and for this part we used this formula. Understood the step, my children? Right. Now let us simplify this first term. What will you get? Minus x cos 3x by 3. Okay, my children, understood this one? First term. Right. Here minus of my, in the square brackets, what will you get? Minus 1 into minus cos 3x by 3. Not 1 minus. Okay, my children, 1 into. Okay, my children. So minus integral, minus of minus, we get plus only. Don't be confused here, my children. This is not 1 minus cos 3x by 3. 1 into minus cos 3x by 3. Okay, my children. Then what will you get? Minus of minus plus integral. I will write 1 by 3 numerical coefficient. This is 1 by 3 is a numerical coefficient. Integral cos 3x. I wrote this integral numerical coefficient outside. Then what will be left here? Integral cos 3x dx. Understood this step, my children? Right. That is equal to minus x cos 3x by 3 plus 1 by 3. Again, it is in the form of integral cos of ax plus b. Cos of ax plus b. What is the formula? Sin of ax plus b by a means x coefficient. X coefficient, that is 3. Because integral cos of ax plus b dx is equal to sin of ax plus b whole divided by a. By using this integral formula, we wrote this part where a is equal to 3, b is equal to 0, constant term is not given. Okay, my children, understood this part? Right. Now let us simplify this second term. We have already simplified first term. So we write this first term as it is. Minus x cos 3x by 3 plus 1 by 9 sin 3x. So integration part is also over and simplification part is also over by this step. So this is the final step. So at the final step, at the last step, we have to add constant of integration. Remember this point also, my children. Okay, my children, understood? Right. Now come to the next question. Third question, my children. Integrate x square into e power x. Understood this question, my children? We have to evaluate integral of x square into e power x dx. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral of x square into e power x dx. We assumed this integral I is equal to integral x square into e power x dx. Here also we are finding the product of these two functions. X square is the first two, x square is one function and e power x is another function. So when you are finding the integral of product of two functions, we have to arrange the two functions in this order, in this islet. What is this function here? X square is a algebraic function and this is e power x is exponential function. See here a e. See here a first letter and the last letter is e. In the same order. The functions are in the same order. First should be algebraic and last exponential function. So these two functions are in the same order, which is convenient to us to integrate this product easily. Okay, my children. Then we can apply integration by parts method. Okay, my children. Right. That is equal to what is first function? X square. First function into integral of second function minus integral of square brackets d by dx of first function. In your mind, you have to memorize that sentence, my children. D by dx of first function into integral second function whole dx. Okay, my children. By using integration by parts method, we wrote this step. Okay, my children, understood this step. First function into, this is considered as first function, e power x is assumed as a second function. So first function into integral of second function minus integral of d by dx of first function into integral of second function whole dx. Okay, my children, understood this step? Right. Now let us evaluate each and every term. X square into integral e power x dx. What is the value of integral e power x dx? E power x only. Okay, my children? Right. Integral of d by dx of x square. What is the formula? D by dx of x power n. We can use here d by dx of x power n, where n is equal to 2. So 2x. Okay, my children? Understood this? 2x. Right. Integral e power x dx for formula e power x only. whole dx, because integral e power x dx is equal to e power x, and d by dx of x power n is equal to n into x power n minus 1. We used this integration formula, and we used this differentiation formula to write this step. Okay, my children, understood this step? Right. Let us simplify this first term. X square e power x minus, here 2 is a numerical coefficient, we can write it before the integral sign. So minus 2 into integral x e power x dx. Okay, my children, understood this part? Right. Again, if you observe, this is also product of two functions. This is the first function, this is the second function. Again, we have to apply integration by parts method for this part. Okay, my children, to integrate, to evaluate integral of x e power x dx, we have to use again integration by parts method. Okay, my children, right. X square e power x minus 2 into, again we have to assume that this is the first function and this is second function in your mind. We have to assume that. So first function into integral second function minus integral of d by dx of first function, d by dx of first function into integral second function. Okay, my children, whole dx. Understood this step, my children? Again we applied integration by parts method to evaluate this integral. First function into integral of second function minus integral of d by dx of first function into integral second function whole dx. Okay, my children, understood this part? Right. That is equal to x square e power x. We write this first term as it is, minus 2 into x into integral e power x. What is the formula? E power x minus integral of d by dx of x. What is the d by dx of x value? 1 into integral e power x dx. E power x. Understood this step, my children? Because integral e power x dx is equal to e power x, and d by dx of x is equal to 1. We used this integral formula and this derivative formula to write this step, to write this part. Okay, my children, understood? Right. That is equal to x square e power x minus 2 into x e power x minus integral, what you get? 1 into e power x, e power x. So integral e power x dx. Okay, my children, understood this part? Understood this step? Right. That is equal to x square e power x minus 2 into x e power x minus integral e power x dx formula. Already I have written integral e power x dx is equal to e power x. So I am not writing again that formula here. Okay, my children, because I have already written integral e power x dx is equal to e power x. So for this we use this formula. Okay, my children, understood? Right. That is equal to x square e power x. Integration part is over. Now let us simplify this function. Minus 2x distributive property. Minus 2x e power x minus into minus plus 2 e power x. Simplification part is also over. Plus c. Plus c. Otherwise, if you are interested, you can take a common factor. You can stop by this step. Otherwise, you can take a common factor. What is common factor? E power x. E power x into x square minus 2x plus 2 plus c. You can write this step also. You can stop by this step, or if you are interested to simplify further, if you want to write answer, this also correct. Okay, my children, understood? Right. Now come to the next question. Fourth question. Integrate x log x. Understood this question, my children? We have to evaluate integral of x log x dx. Okay, my children? Right. Come to the solution part. Let us assume that capital letter I is equal to integral x log x dx. Understood this step, my children? Right from the beginning of this integrals chapter, I am explaining this first step. We are assuming the integral of the given function is a capital letter I. Okay, my children? Right. Now let us check whether these two functions are in the convenient order or not. Okay, my children, to apply integration by parts method. So here x is a algebraic function, and here log x is a logarithmic function. Here algebraic function and logarithmic function. The functions are given in this order. But what should be given? What should be first? Logarithmic function should be first. Next algebraic function should be. So, but in the reverse order, the functions are given. This product of these two functions. The functions are given in the reverse order. The first question itself, I told you, sometimes they will give in the reverse order. So we have to arrange, we have to rearrange that functions. Okay, my children. So integral, before applying that integration by parts method, we have to rearrange in this order only. So log x into x dx. So we rearranged the functions for our convenience to apply integration by parts method. Okay, my children, understood this step? Right. First function should be logarithmic function, and next should be algebraic function. But they are in the reverse order. So we rearrange it. Now we can easily apply now integration by parts method. Here first function is log x and second function is x. Okay, my children? Right. So first function, that is log x, into integral second function, integral of second function, minus integral of d by dx of first function into integral of second function whole dx. Okay, my children? According to the statement of integration by parts method, first function, that is log x, into integral of second function. We assume here first function is log x and second function is x. So first function into integral of second function minus integral of d by dx of first function into integral second function dx. Okay, my children? Right. This is equal to log x into, what is the value of integral x dx? It is in the form of integral x power n. So x power n plus 1 by n plus 1. What do you get? I wrote directly here. 1 plus 1. What do you get? 2 by 2. Understood this x square by 2, my children? I wrote the value of this integral x dx, x square by 2. Okay, my children? Right. Minus integral of d by dx of log x. What is the value of d by dx of log x? 1 by x into integral x dx. We have already found here. What is that formula? X square by 2 whole dx. Because what is the formula we used here to evaluate this integration? Integral x power n dx, where n is equal to 1. Okay, my children? X power n plus 1 by n plus 1, and differentiation formula d by dx of log x is equal to 1 by x. We used this integration formula and differentiation formula. We use these two formulas to write this step. Okay, my children? Understood? Right. Let us simplify this first term. X square into log x by 2, x square into log x by 2 Okay, my children, we get this first step as x square into log x by 2. Now come to this part. Here x gets cancelled. What will you get here? Only x by 2. Okay, my children. So 1 by 2 can be written as outside numerical coefficient. Final what will get? Integral x dx. Understood this here? 1 by 2 integral x dx, my dear children. Here x gets cancelled. What will be left here? X by 2. X by 2. So 1 by 2 can be written as outside numerical coefficient integral x dx. Okay, my children, understood this one? Right. That is equal to x square log x by 2 minus 1 by 2 integral x dx. We have already found integral x dx is equal to x square by 2 into x square by 2. Here I am not writing again this formula because we have already found integral x dx for value is x square by 2. We used this same result here. Okay, my children, understood? Right. So integration part is also over. Let us simplify the terms. That is equal to x square log x by 2 minus what we will get? X square by 4. Isn't it or not, my children? Right. So integration part is also over. Simplification part is also over. This is the final step, last step. So at the last step, we have to add constant of integration. Do you remember that point, my children? Right.